have these great unsolved mysteries that span from the scale of our own solar system all the way out to as far as we can see in the universe that we wouldn't have any idea why it was happening.
Einstein saw gravity as a curvature of space. If you have something massive, like a star, such as our sun, it'll make a gravity well. So during an eclipse, if there's a star over here and you know exactly where it is, during that total eclipse, it'll appear to be over here because its light has been bent. That's the Einstein experiment.
If I might prepare apparatus and accompany him, and he was cordially agreeable. This led to one of the greatest experiences of my life.
This expedition to prove that matter can bend light, this was one of the first examples of making a measurement on the scale of galaxies.
Surrounded by flies and dust and suffocating from devastating heat, they only had 5 minutes during totality to point their Einstein camera and get their evidence.
And this was stunning. This absolutely changed the way that we thought about how we view the rest of the universe.
The 1922 expedition laid the groundwork for what we know today as big science, which continues to prove Einstein right. When the Dominion Astrophysical Observatory opened here in Victoria a little over 100 years ago, it was the largest operating telescope in the world. And others like it blossomed all over the planet, opening up the heavens to observers like Chan. These are not relics. It's been refurbished. It's still used today. It's 10,000 times more sensitive than it was when it was built.
If we didn't have Einstein's theory of relativity, but we did continue to build these bigger telescopes and we did continue to probe farther and farther out into the universe, we would see a lot of things that we just can't explain. We're at a very interesting point in scientific history right now where we're finally able to sense these space-time distortions and really get a sense of what's out there in the dark that's moving really quickly.